and welcome to this episode of SPSS one-on-one series with Warrior Analytics. Today we look at how to use factors extracted from factor analysis as new variables for further analysis in multiple linear regression model or other models. Remember, the main goal of factor analysis is to reduce the large number of variables you may be having into smaller groups that can carry more meaning. Consider our study that is aimed at understanding employee perceptions of teamwork and job satisfaction, and we carried out a survey using 10 questions recorded on a Likert scale ranging from 1 for strongly disagree to 5 for strongly agree, and we have a total of 500 participants. So this is how our data would look like. We have 1 up to the 500 participants. Then we also have the number of questions from 1 up to 10, but each of these questions has a name. But in factor analysis, we quite often refer to them as items. So we have our item 1 to item 10. So the purpose of factor analysis is to help us group together related variables or to help us establish those underlying structures. And when we did a factor analysis in our previous episode, we identified that this data can be grouped into 2 distinct groups, which we call factors. Factor 1 having these 4 variables, and factor 2 having 6 variables. And this factor 1, we gave it a name as team dynamics, whereas factor 2, that's the job satisfaction. So the common factor analysis, or the principal axis factoring, the way it is called in SPSS, ends here at just establishing for you those underlying structures. But sometimes you want to reduce those variables into smaller groups of fewer variables called factors, and now those factors become your new variables for further analysis. So that's what we are going to do today. We started with 10 variables, okay? And these 10 variables underwent factor analysis, and we obtained factor 1 and factor 2. In your extraction, you may even have more than 2 factors. So what we want to do is, how do I now use these results of factor analysis, the 2 new variables, to use them as new independent variables to assess the relationship between them and my outcome of interest. Our outcome of interest is employee performance. So let's go to the computer and see how it is done. So we have here our 10 variables that assessing perception and job satisfaction of our participants. But additionally, we have a variable called employee performance. So we want to reduce these 10 variables into fewer factors or groups that we can now use to assess their effect on employee performance. So here is our data set that has got 10 variables that we want to reduce into groups of related variables, and then those groups which we call factors are the ones that we are going to use for further analysis as new variables to establish the relationship between them and employee performance as our outcome in multiple linear regression analysis. So meaning we start by running a factor analysis, click on analyze, then go to dimension reduction, click on factor, and then you're going to put in all your items from number 1 to 10 under variables. Then under descriptives, we are going to select coefficients, significance levels, determinant, KMO, continue. Under extraction, we are going to use principal components here by default, but we have a previous video that covers what do you consider when choosing which type of extraction method. The link is in the description of the video, which depends on the goal of your analysis. If the goal of your analysis is to do data reduction so that you come up with fewer variables for further analysis, then principal component analysis is the best. Here you can check off the script plot and then we click continue. Then under rotation, we are going to use the orthogonal methods of rotation because our goal is to have variables for further analysis. So these orthogonal approaches assume that the factors extracted are not correlated. Like I said, we have a previous video. I highly recommend you go and see how we described this in detail. So we are going to use the Varimax and then click continue. Under options, we are going to click on sort by size and we want to suppress small coefficients below 0.3. Then click continue. So click OK. So here we have our output with the correlation matrix. For you to be sure that your data is fit for factor analysis, you should at least have a correlation coefficient of 0.3 and above. This is KMO, which measures factorability of your data. We are interested in a value of 0.6 and above. Then Bartlett's test, we are interested when statistically significant. We have here a table for commonalities and the cumulative percentage of variance that is accounted by the two factors. We have explained this in detail. Please consider checking that previous video. And the script plot, which shows you the number of factors that can be extracted based on EGN values above 1. There are only 2. We have the component matrix. We have the rotated component here. This is where our focus is going to be. You can see that out of these 10 variables, variable 1, 2, 3, 4, they are all loading on factor 2. Whereas variable 5, 6, 7, 8, 9, 10, they are all loading onto factor 1. Please note that all those empty cells we are seeing have got values in them, but because we suppressed correlation coefficients below 0.3, they are not displayed. They have values, but the correlation coefficients are all below 0.3. Note that if you run your analysis and you find that an item or a question loads on more than one factor with a correlation coefficient above 0.3, consider that variable under a factor where it loads with the highest correlation coefficient. And here we are interested in the magnitude of the correlation coefficient, not the sign. So this is where we started from, saying in our previous analysis we got factor 1, which had item 1, 2, 3, and 4. And then when we look at these 4 variables, the common name that can bring these 4 variables together is team dynamics. Whereas these 6 variables, if we called them job satisfaction, that would be good enough. Now that we have got 2 factors, how do we use them as variables for further analysis? Now, we have got 2 approaches that you can use to create overall scores from the different items or variables constituting a factor. The first one is the composite, having a composite score, which comes by default in SPSS. We can just simply go to under analyze dimension reduction factor. Then where we have scores, we are going to save variables. We want one variable that summarizes all the items in that factor. So there are several. There are some differences between these different approaches. For now, we are going to use the regression approach. Click continue and then OK. So when you check our data set, you find that our two factors that have been extracted, we now have one overall variable for these two factors. So we can now use these two factors as new variables for our further analysis. So if we wanted to find out the relationship between employee performance and now these two variables in multiple linear regression, we would simply go to Analyze, Regression, Linear Regression, and then these become our new variables under independent variables, and employee performance becomes a dependent variable. Under statistics, we can choose the R squared, the descriptives, maybe collinearity diagnostics and others. We click continue and then click OK. So here we are interested in this coefficients table where we have the two variables, their coefficients and the significance levels. From this, we can see that these two are not statistically significant. These two variables, which we are calling team dynamics and job satisfaction, are not significant predictors of employee performance. We have a separate video on multiple linear regression where we explain all the steps, how to check for assumptions, how to interpret these values, how to interpret the VIF and tolerance for collinearity. I highly recommend that you check it out. The link is in the description of this video. So that is one way you can use the results of factor analysis for further analysis, using factors as new variables for your further analysis. The biggest limitation of this approach is that they are hard to interpret. Because now if you ask, what does 0.325 mean? It is very hard for a lay person to understand. And because of this limitation, there is an alternative of using summative scores, where you simply get scores like the average, the sum of the individual variables to come up with one single variable. Now, for example, here we are going to get the average of these four variables into one variable, and then we get the average of these 6 variables into a variable called job satisfaction. So that means we shall start by computing our variables. Simply go to transform, compute, and then we shall start with team dynamics, where we are going to get the mean. So here click on all and then look for the expression for mean. The mean is here. I click on it. I use this arrow to push it in the expression box. So there are 2 question marks there. You specify all the variables that you want to calculate the mean for. I'm going to calculate for variable 1, comma, again variable 2, comma, variable 3, comma, and variable 4. Then I'll remove this last question mark, and then I'll click OK. Then when you look at our data editor, we have got a new variable called team, which is the average of the individual variables in that factor. So we do the same for the other variable called job satisfaction. Let me just use job. Then we are now replacing these variables here with the actual variables from 5, comma. You keep separating them with commas. Click OK. And then when we go to our data set, we shall be able to see that we have a new variable called job satisfaction. We are now going to use these two variables as our new variables for our multiple linear regression analysis. So which we can still go by analyze, regression, then linear, and instead of the other ones we calculated from SPSS, we are going to use these two, push them there, and then click OK. And then we are also interested in the coefficients table. We have team and job. Then we have significance levels. You can see that both of them are non-significant. So those are the two ways how you can utilize the results of factor analysis or exploratory factor analysis for your further analysis in regression. As usual, if you find these videos helpful, consider liking and subscribing. I'll be very grateful. See you in the next episode.